say our, wait, am I still converting this thing? Yeah, I am. I'm converting the other one to a video right now. I would say that we could in fact do another review tomorrow, but if we were to do another review tomorrow, it's probably better we do it earlier in the day.
I'm sorry, I didn't hear you. What?
That works for me.
Yeah, so if so it depends on how long this runs. So we'll try and get like a nice representative amount of questions done here through these reviews. But if like we're reaching like the 2-hour mark and we're like halfway through, we're obviously going to stop and try and get another review session in tomorrow, probably earlier in the day to give people time later in the day to study for other exams. I know I have linear algebra that same day. I'd like to get some studying for that in as well. So I would say we do, it really depends on how, like we might be able to grind through a bunch of these quickly. Like I know like early topics are going to be fast. Like I doubt we're even going to spend a lot of time here, but here's what we really need to do. We need to look at his breakdown. And we need to understand what type of questions that he'll ask, right? And we also need to understand that chapter 15 is its own entire thing worth 30 points and he's asking 3 questions from it.
So there's only 11 questions on the final?
Yep.
Dang, not bad.
It doesn't sound that bad. And as he said it right here. He's giving it in 3 different parts, each with a different passcode. And you'll have a short break between, which is cool.
So if I'm right, he's saying each of them will be like 45 minutes.
Probably.
Give or
And
take, yeah.
I think that will give us like 2 hours and 15 minutes. And the final time for this class is 2.5 hours.
Yeah, so there's like extra time for the breaks built in.
Yeah.
So that's cool. Yeah, so all right, I think everyone who's going to join is going to join for now.
That's civil public speaking. Sorry, I'm looking at something else right now.
Yeah, I'll be right back. I'm going to go to the bathroom real quick. I'm not going to bring my headset. That would be stupid. Yeah. I'll be right back.
I don't want to look at fallacies and logical deals. No.
You want to look at my physics exam instead? Woo. I'm kidding. I gotta say though, I have a physics final due tonight.
Oof.
And I need like a 30 on it to pass the class.
For the
No,
lab?
I need a 60. No, I already did the lab one. This is my like actual.
Gotcha.
Because my teacher was just like, okay, it's 50 questions that you can do like within a span of a week. And I'm like,
Gamer time.
well, thanks.
What, you talking about a wacky long file or something?
Yeah, it's 50 questions, but they're spaced out. They gave us like a week or 2 to do it.
What class is this?
Physics, and it's due tonight. Physics 2.
The question is,
Oh,
did
hey,
you
a
do?
bunch of grades.
Did you do
Like
most
math.
of them?
Heck are these for?
Right now I'm sitting at about like 40 out of 50 done.
Oh, and it's due tonight. You shouldn't have too big an issue, hopefully.
Yeah, I've been working on it all today. Yeah, I have.
Yeah, got my final exam SIE points. Yeah.
Did you just enter them?
Yeah, a bunch of things like labs and all sorts of stuff.
Yeah, my grade shot up like 3.5 points.
Also, I loved
Yeah,
it that on Tuesday, I kept looking for the attendance quiz. Like I checked it several times throughout the class and it never showed up. And so it logged out, it like timed out before I could actually do it. Because it never appeared.
That's a big goof.
Only class I missed.
Attendance. I have a 92.5 in attendance, or 92.6. Because I missed one class apparently. I thought I missed a lot more.
Yo, my homie gave me the 5 points.
Yeah. I'm gonna need those. I suck at testing on calculus.
Yeah, I'm definitely gonna want those points as well because it just gives me more room
Buffer.
to breathe, right? So I definitely I like that. Now I can do. Now I
We can
do
play the
more.
game like how much can we fail and still get an A?
That's what I'm talking about. That's what I live and breathe that. I'm gonna test that right now. What happens if I get a 70? I get a 70. I have an 89.1. I'm set. I could just get 1 point Get one single point from chapter 15 and be fine. All right, let's go. Gamer time.
Gonna fail the test. What?
Gamer time. Let's hit it. All right, we're gonna start off. I know for a fact chapter 11 and 12 we're probably gonna breeze through it like no tomorrow. We'll probably do like 5 to 10 questions because they'll probably all be relatively quick.
One sec, I gotta switch things out. Which one's my math folder? I have like 7 different notebooks on my table. No, that's data structures, which I'm gonna fail.
All my homies don't like failing data structure.
Well, it's just data structures. You get to the point where you're doing things that build off of each other a dozen different ways.
Yeah, I understand.
So when you have a 100-point project and only 4 homework assignments,
it hits. Yeah.
Yeah, especially when you have an unresolvable linking error in your program, which you look at for hours upon hours and still can't solve. So you automatically lose points.
Yeah, sometimes you just gotta explain your code to a duck and you'll fix it.
Well, yeah, I know about the rubber ducky problem. I got my own personal
legend. All right. Well, sometimes it's how it be. All right. So we'll literally just go in this one. We'll just go order wise. So we can start with just number 1 for 11. Number 1 is we're given a u and a v, and it says find the component form of the vector and the magnitude of the vector. So to start with component form of the vector, if we do 3 times vector u, which is -3, 4, that's a scalar multiplied but crossed by a vector. So to do -3, 4, that's a scalar multiplied through by a vector. So 3u becomes -9, 12 minus 4v, where v is 2, -5. So you will then have minus 8, because 4 times 2, and then -20, 4 times -5. Now you have a vector minus a vector. And since we're doing like elementary operations, addition, subtraction here, we can simply do this entry by entry on the vector, you know, x minus x, y minus y, entry 1 minus 1, entry 2 minus 2. So in this instance, the component form of the vector for number 1 is going to be -9 minus 8 for the first entry, and then 12 minus -20 for the second entry, which will yield us -17 for the entry 1, and will yield us 32 for the entry 2, because 12 minus -20 is 12 plus 20 is 32. Any complaints on that for a component form?
Nope.
One second, I'm just working through that.
No problem.
Okay, so does he have solutions for the ones that you circled, or do I need to pull them up?
He has not for all of them, some of them.
I will pull them up.
Number 1, he doesn't have. Yeah, just pull up the textbook solutions. But number 1, he doesn't have solution for. But component form should be easy. Now, magnitude of this vector is, in order to find the magnitude of this, vector combination, the first thing you have to do is find that component form of the vector that we already found, and then to find its magnitude, isn't it just like the square root over the square root of each component? If I remember correctly.
Magnitude was
it's the distance.
It's the square root of adding them both together.
Yeah. So it's under the square root of this, like, entry 1 squared plus entry 2 squared.
Okay, yeah.
Yeah, that's what I thought. All right. If that is the case, then that means we would do the square root of 17, -17, but it really doesn't matter. Sign-wise, it's being squared, plus 32 squared. Those numbers are too big for my tiny brain. I have to use a calculator for this one. 17 squared is 289. 32 squared is 1024. That's actually pretty nice. Plus 289 is 1313. That's really funny. This seems like it's going to be a perfect square. It isn't. It's 36.235, but obviously that's not what we're going to write on the test. We don't get a calculator. So we must reduce it ourselves. The square root of 1313. Well, I have a sneaking suspicion that 1300. No.
Why did I do that? I know.
Yo, I want to remember the closest perfect square to 1300. Lower than it, that is.
1313?
The closest perfect square that's less than 1313.
1313 is not divisible.
I know it's not. I know it itself is not a perfect square, but we can still reduce it, right? Or do you want to leave it? Do you
It's
think he cares?
13
Pretty
times
sure you can
101.
reduce it. I'm just running through a bunch of the basic ones right now.
It's
I
13
think we'll
times
be able to
101.
leave it. I don't think he'll expect us to reduce that.
Yeah, you're right. So in this instance, we'll leave it. If it were an easier to reduce, I recommend reducing it. But if it's more complex to reduce, you can probably, it's in your best bet to leave it.
Yeah,
Yeah,
I've
but
gone
see,
through the basic
you can
12
break
and
it
I
up
can't get
and you can break it up into 13 times 101. And we know that 13 doesn't square root, and we know that 101 doesn't square root because it's 101, not 100.
Yeah,
It's
so
one off,
just
then it doesn't do
square
it.
root of 1313.
Yeah, well, ripperoni. Sometimes it's how it be.
Mm-hmm.
All right.
Sometimes it'd be
There's
like that.
so that is that one. So our component form for question 1 was -1732, and our magnitude for that component form is the square root of 1313, or 1313. Now, exercise 5 through 8 is finding the component form of a vector. Now, this looks
Nice.
interesting. Rotating them, a unit vector. So this is just a bunch of different ways to ask questions. So I know he has the solution to number 6 in his solutions, so we should probably work this one to start.
Yeah.
So the unit vector that makes an angle of pi over 6 radian with the positive x-axis. So let's doodle that. So
By the way, the answer in the back of the book is -1732, and then square root of 1313.
beautiful. All right, so number 1 was confirmed correct. So for number 6, the unit vector that makes an angle of pi over 6, or 30 degrees, with the positive x-axis. So we can draw our Cartesian coordinates and then draw a 30-degree line, which is also pi over 6, right, from the axis. So it would look like that. So that's what we're looking at here. And that's the unit vector we're looking for is that line. So
So we
unit
have
vector,
we have a hypotenuse of 1 with an angle of pi over 6. So then we just use
yeah.
Trigonometry.
Yeah, so
Defined.
the reason John knows that the magnitude is 1 is because the definition of a unit vector is it's a vector that's scaled to have a magnitude of 1.
So it's going to be 1 square root of 3. Yes.
No, it's gonna have we have to find the component form. That's what the question's overall asking, and then each of these each of the numbers gives us a condition, and then we have to figure out how to find the component form of each of these. So the condition here is given as a unit vector that forms the angle pi over 6 with the positive x-axis.
Yeah.
So we know the magnitude is 1, as John said. So we can use, and we have an angle, so we can use Pythagorean theorem, I believe, to find the lengths. Or no, we can use trigonometry. We can use a bunch of tricks to find the.
This is basic trig.
Yeah, we need to find x and y. So I will start with x. So
It's also
we have,
the
Yeah,
unit
it's
circle.
1 and square root of 3 because the triangle with the in trig is triangle with the radius of 30 degrees or
angle 30 degrees. Yeah.
Of pi over 6 is the hypotenuse is 2. The
Well, in this case, the hypotenuse has to be 1.
And the y is 1, and then
So it's
the
1/2.
no. It's,
Well, if the hypotenuse is 1, then the opposite is 1/2.
no,
And
I said the
also-
hypotenuse is 2.
No, but in this instance, it has to be 1 because it tells us it's a unit vector.
Yeah.
So the magnitude of the hypotenuse has to be 1 in this
Literally,
question.
like, it's literally root
It's- yeah, it's
3
just
over
like-
2I plus basic trig.
Yeah. So let's
It's
see.
also the unit circle.
Oh boy,
Yeah.
I don't want to hear about the unit circle. So what did
But
who just vote? Was that Jeffrey or Alex? I didn't see.
It was Jeffrey.
That's me.
Who said the
All right,
answer.
it was Jeffrey. So what did you say it was? What did you say your IJ was?
Root 3 over 2I plus 1/2 j.
And did you just use, cosine and sine for that? Or tangent? Just those 3?
Yeah, you
Two of
just
those.
need cosine and sine.
Yeah, so you can just use cosine and sine and just use the inverse functions. Hopefully you know your unit circle, because this is in radians and it would probably suck to not know how to do those. But this is just, you use the sine, you just do the inverse sine, inverse cosine, and you solve for your values.
No, you don't need to do inverse.
You don't
just
even do
take-
inverse? That's
No, you
bold.
just take cosine of pi over 6, and that's x. And then you take sine of pi over 6, and that's y.
Oh, yeah,
Because
you're right.
cosine theta over.
then-
Because our
Yeah.
magnitude is 1. That's awesome. Yeah.
Yep.
All right. Yeah.
After you
there's
take
that.
cosine sine, you multiply it by magnitude.
So
which in
who
this
said
case is
so?
1.
So our y was √3/2, and our j was what? Was it the same, or was it? No, it
1/2.
can't be. Yeah, it's 1/2.
Mhm.
All right. There's that one. So that's a way to solve that. So let's look at the other ones and see if there's any ones that are interesting here that we might want to look at. The vector 2 units long in the direction 4i minus j. So that one. And then the other one's the vector 5 units long. So it gives you a magnitude and a direction. And it's asking you to find the component form.
What I would do is I would find the magnitude of that and then divide the vector by the magnitude of the vector to get a unit vector, and then multiply the vector by 2.
Yep. That's how you solve it.
And that's done. That's what this whole thing is.
Yeah, so you basically just multiply it and put
Yeah.
in the.
So, and this one's asking the exact same thing, similarly. It's give you another magnitude and it gives you a direction, but it says opposite to the direction of this. So that just means you change the signs, right?
Correct.
Yeah.
Yes.
So you just modify this slightly. It's the same process there. And then this one is the vector obtained by rotating that's a vector. It's a component form vector through an angle of 2 pi 3 radians. So, what is it? Pi over 3 is in degrees, it's 60, right?
Yep.
So 2 pi over 3 sits us at 120 degrees. So you would have your 0, 1 goes up along the y-axis initially, and then you rotate it 120 degrees. Ugh.
It's actually the same thing that we did in number
Yeah, it's the
6.
same thing. It's just how to set it up. Because at the end of the day, it's still being set up in relation to the Cartesian coordinate set. So it's not that bad. It's just that one's more annoying because you have to do a little bit more work to set it up. But then it's the same process because you just set up a right triangle. All right, so we're done with these ones. Done enough of those. Express the vectors in exercise 9 through 12 in terms of their lengths and directions. All right, so we have a velocity vector, and then we have just regular like pleb vectors. Oh, oof. So when it says lengths and directions, doesn't this mean we get the magnitude thing and just do the whole 1/magnitude times the vector thing?
Yeah.
So it's the exact same thing as described here. It's a unit vector.
Yeah, so the length is going to be our magnitude, and then our direction is going to be the unit vector.
Yep. So yeah, and in order to get a unit vector, we simply we multiply it by 1/magnitude to scale to a unit vector, and then we multiply by the magnitude again. Right. So here's our vector, which is given to us in that question. This is our direction to scale it to unit vector status.
And
And then we just.
The direction is just going to be the unit vector.
So this question, we just give them a unit vector.
Yep, and the magnitude.
Okay.
Well, you need the.
It's 2 separate parts. There's 2 separate parts of this: the magnitude, which is also known as the length, and then the direction, which is also known as the unit vector.
So for number 9, the length is described by the square root of 2 plus 2. Oh boy, it's equal to 2. So our unit vector scalar is just 1/2 times. So it's going to be √2/2 I plus √2/2 j for our unit vector. And then now that we have our unit vector, is that it, or what do we multiply by the magnitude again here? No, that would just cancel.
Yeah, because it's just multiplying the.
Yeah, now we're done.
The...
So that's it. So it literally is just this equation. Beautiful. All right, so that's how you do that. Yes. If we look at 11, it looks more complex, but it just gives you a t. So the sine and the cosine will evaluate to a number, and then you just do the exact same thing that we just did. You take the magnitude of the coefficients on I and j, and then multiply the original I and j set by 1 over the magnitude. So all of these are plug and chug run through, same exact process. It's just 11 and 12 look scary because they added, non-numbers and functions in it, but it's still just the same. Same with 12, but we don't even ask to do that one, so we won't work through this because that's the same process. Express the vectors 13 and 14 in terms of their lengths and directions. This is the same question.
But
It's-
in 3 dimensions,
Oh boy.
which is the exact same thing.
Oh
But
boy.
yeah,
Who would have thunk it? All right. Well, just for those who don't understand, if you add a third dimension, in order to find the magnitude, you simply add another squared term to the sum underneath the square root. So for example, 13, the magnitude of 13 is going to be 2 squared plus 3 squared plus 6 squared all over all under the square root, which is 4 plus 9 plus 36,
which is 7.
which is 49. Square root of 49 is 7, as you said. Checkmate. That's the magnitude. So then in order to finish this problem up, you do 1 over 7 times that vector. So the end result is 2 over 7i minus 3 over 7j plus 6 over 7k. And that would be the end of that problem. Number 15, real quick, I'll explain it, but we won't work through it. Find a vector 2 units long in the direction, whatever there. So in that instance, you're scaling a unit vector.
Reversing its signs.
Now, in this one, it's not changing the direction, right? It's saying find a vector 2 units long in the direction. So
Oh, sorry, I was looking at number 16. No, you're good.
yeah, so what we do here, isn't it? You find the unit vector of that vector, and then you multiply everything by 2?
Yes.
Yeah, okay.
He likes to test that question a lot.
Yeah, so when it
That's like
comes
his
to
go-to 11 check.
So when it comes to that question, don't be confused here. You still do the same thing with that given vector, that 4i minus j plus 4k. Just find the magnitude of it and scale it to a unit vector using the same formula we've been using for the past couple of questions, just 1 over the magnitude times the original vector. And then you take that new unit vector, which is scaled to 1, and multiply it by whatever scalar he gives you, whether it be 2, whether it be 5. And in this question, it's an additional level of difficulty because you simply invert the signs on this vector because he says in the direction opposite. Either way, same process across the board. Okay, we're back up this way now. Yeah, back up this side. All right. We'll do like 1, 2. Oh boy, there's a lot.
Yeah, that's kind of the problem with doing some of these.
Yeah, so
When he just gives you the.
he just gives a lot, but a lot of these are just the same. So let's just read what 25 is asking. Find the area of the parallelogram determined by vectors u and v, and the volume of the parallel piped determined by vectors u, v, and w. So there's just formula chunks for this, if I remember correctly.
Is this not cross pro?
Yeah,
Hmm.
who remembers? I remember. Like I know we all did well in this test, so I know we did it at some point. Oh, here's an idea.
I have my papers. Papers,
Yeah,
please.
don't we have like the beautiful, awesome ability to go to our assignments
Yeah.
and then go to our where is
I
it?
have my Calc test 1 here.
Yeah, I'm gonna open my work for test 1 if I could find it for the life of me.
Should be near the bottom.
Yeah, you're right. Submit work, it should be here.
It's the absolute value of the cross product.
Legend. What did you say? Is the absolute value of the cross product?
Yeah.
That's it. Legend.
Okay,
Wait, so
and then what's the other one?
Parallel piped, I think it's just a cross product of everything, but I'm still looking.
all right. We probably did something like this, so I'm gonna continue. So we have plane stuffs, which we'll be doing in a second.
Mm-hmm.
You
Gotta know
know,
how to do your.
I made 102 on that test.
How I got
so
wrecked, I did
I
103 nerd. We didn't even do it.
Is it? And we didn't get a sheet.
Yeah, we didn't even do it. That's sus.
Because I got like 2 line stuff and
Yeah, that's sus. We did this. Look. He just did this. There's one question from this thing. But then there's like a million questions from that. I really don't think this is gonna show up.
I don't
Yeah.
remember us covering that. I can
We-
go through my.
I know
notes.
we covered it, but just like in Cal B, because we also discussed something like this in Cal B for 2 dimensions, obviously. Because the
Mhm.
parallel pipette is the 3-dimension version, the parallelogram is the 2-dimension. So we did the parallelogram in Cal B. And I know for a fact that that didn't show up on the Cal B test either. That's just like a cool little interesting idea because of the fact that when you have 2 vectors like this, because of the nature of how those vectors operate, you can scale them like this, and then it'll form a parallelogram by moving the vectors and boom.
Mhm.
So, but it never shows up. So I really don't think we should work this because I don't think it's going to show up. That's actually a good idea. We can look back at our old tests and find out what kind of stuff will show up based off of what he thought was important to test on.
The parallel pipette is actually U cross V dot W.
U cross V dot W, and that's it.
At the
Just-
area of the parallelogram, and then you dot that to get W.
with dot that with W because that's the next dimension.
Yeah.
All right, cool. Well, we know how to do it. So,
And then you take the magnitude of that.
just have that written. Just write those formulas down for later, since we'll probably try and throw together a formula sheet again. At some
Someone
point.
making like the ultimate formula sheet, or do I have to keep up?
No,
Just-
I will.
Just keep those
Just start
formulas.
typing it up so then everybody can print it off and then write it out themselves.
Just keep those formulas written down for later when we have like our last call for formulas, because he has a bunch of them. And here's something that's even funnier. He left those formulas off the sheet.
Yeah, you did.
There's no way in hell it's showing up. Absolutely no way. All right, let's continue on to the lanes, planes, and distances.
Remember it just in case, but don't.
Yeah, we'll
Don't
write it down just in
anticipate it.
case. All right, lines, planes, and distances. We'll start and read the first question. Suppose that n is normal to a plane and that v is parallel to the plane. Describe how you would find a vector n that is both perpendicular to v and parallel to the plane. So it
All
has
that
to be-
comes to mind is orthogonal.
yeah, so n is perpendicular to the plane, v is parallel to the plane. You need to
Mhm.
find a vector n that is both perpendicular to v and parallel to the plane.
Doesn't it have to be?
Yeah, so this
It's
should
like
just be.
one of the formulas that equals 0 or something.
So there's some vector
Like dot
v.
product, cross product, right?
Yeah, some vector v that's parallel to a plane. So we're looking at.
Okay, here it is. The cross product of the direction vectors of 2 lines in a plane is parallel to the normal of the plane.
Oh, but we're given in this one we're not given 2 vectors in a plane, right? We're given a vector that's already normal to a plane and v that is parallel to the plane. Describe how you. Oh, okay. I figured it out. So you need to find in a normal vector n that is perpendicular to v and parallel to the plane. So you would have to. Okay, so we need to think about it. So you have your plane,
Mhm.
and then you have v, which is parallel to the plane but not in the plane. Didn't say it's in the plane. And then you need to find a vector n that is perpendicular to v and parallel to the plane. Is that even possible?
I mean,
It's possible, it exists. I'm just can't figure out how to get it.
Doesn't n already meet those qualifications because it's normal to the plane?
But it's
And
supposed to
then-
be parallel.
Oh,
to
you
the
don't
plane.
know if it's parallel perpendicular to V though.
No, but normal means it is perpendicular to the plane. That's the definition of
Yeah,
being normal.
yeah.
And then if v is parallel to the plane, then n is also perpendicular to v.
Yeah, but it wants an n that's parallel to the plane. So it can't be normal to the plane. We might
Oh,
need
so
to
we just
look-
have to cross n and v then.
we would need to cross n and v.
Yeah. So we're doing another. So like, what it's saying is like, imagine that n and v are in a plane, and then to be perpendicular to both, it has to come outside of that intersection or point out.
Okay. Well, yeah, then cross product should work.
Yeah, you would just cross product them.
Cross n and v.
Yeah, that's a very poorly worded question.
Yeah, I don't. It was wacky. I doubt we'll have a question like that. It's probably all
Yeah,
going to be
so
calculation.
the thing I mentioned from 11.5.
Yeah, Ryan probably had it. We just didn't understand the question yet.
It's very
Exercises.
strange. I do not blame you.
Yeah. Exercises 29 and 30 is find the distance from a point to the line. I'm pretty sure this straight showed up in this test. Let's see.
I believe so. I want to say so.
Plane through.
I
I'm
don't
not that
like
good
this
at writing this. So plane through the points. This is just find the equation of a plane or whatever.
Is
Yeah.
it that one? No.
No, I don't think we did
Point.
a point, did we?
Point to a line is oh no, wait, it's distance from a point to a line, right?
Yes.
Yeah, so you take the vector that's given and then you cross it with v. What?
So
It's vector
we have
p cross v
we have
over v.
our-
We have a coordinate.
we have our coordinate, which is our point, and then
Mhm.
we have our line, which is this.
Which ends up being like negative I plus j plus t, all plus t. Okay. Get him. But because you don't plug them in. Now I must consult my chemistry notebook because that's what I wrote in before I decided to use my calculus notebook.
Legend. I'm gonna look back at this one more time.
So it's a formula. So the formula is D equals the absolute value. Wait, okay. I don't know how to write this in a general formula. This is not the correct formula. It is a formula for it, but oh, from the point to the plane.
So the first thing I would expect is we have to actually like figure out how to draw this line. And as you like someone probably mentioned earlier, you can represent a line as a vector.
Mm.
So we're given our point 220, which luckily enough for us means that it doesn't even consider a z-axis necessarily, so that might simplify things. So if we think about this Cartesian wise, that means it's at the point 22, and here's our point, and then we have our line, which is negative I or negative t. Should we keep the t or just?
Well, let's just convert it like it would be a unit vector.
Right, so
I think for
negative
some people
I
that might.
plus.
Guys, I actually think it's a really big formula that is distance equals the absolute value of ax1 plus by1 plus cz1 plus d all over the square root of a squared plus b squared plus c squared. And I remember this part of the formula where the formula for a plane is ax naught plus by naught plus cz naught.
Yeah, it's right here, this thing. But then you have the x and the y and the z with a constant added to them, as you said, with those knots.
And then the normal vector is going to be, yeah.
Well, because you could technically use the non-existent point, because the line itself using the x, y, and t formulas have a point of 0, 0, -1. That's like its point A, if you remember doing those formulas. So I'm not sure. You could connect it that way, because technically, by all technical metrics, you're starting from that point on a line.
Yeah.
What's the? Okay, I gotta click on your.
Yep. So that's the formula.
And
kind of
how do
hard to
we,
see.
but the question is, how do we apply it here?
Well, we're given a point P1, and then we're given a plane. And since there's no Z, we just plug in 0 for Z.
I'm sorry, could you say the formula again? You can just say it.
Okay, so the distance is equal to the absolute value of AX1 plus BY1 plus CZ1 plus D.
Here's the formula in the book. Its distance equals the magnitude of the cross product of PS and V over the magnitude of V.
Really?
That's a much better.
So what did you say it was?
Wow.
I got it on camera right now, if you can see that.
The distance
Its
is equal
distance
to the,
equals the magnitude of vector PS cross V over the magnitude of V.
so PS is formed how? How do we form PS?
So you
That's the
take
vector, the X,
points
Y, and
in
Z.
the parametrization Mababu thingy. Wrong button. And you subtract the point. Where I think you take the point minus. Yeah, you take the points minus the parametrization constant. It's like on 29, like only the Z has a constant. So your cross product would look like on top, you would have for your PS vector, you would have 2 minus the 0, which is 2, 2 minus the 0, which is 2, and then you'd have 0 minus -1, which is 1. So you'd have 2i plus 2j plus k. And then you have your vector v on the bottom, which would just be -1i plus 1j plus 1k. You'd cross those, take the magnitude, and then divide by the magnitude of just vector v.
So
Actually,
let's.
hmm.
So I guess let's start writing it down and see if we get the correct answer.
Mhm.
Yeah.
It is a. Wait, it would be tip minus tail, so gotta do the -1. Funnily enough, I was still kind of right. We did actually have to use the constants for parameterization.
Mm.
That's what we call a lucky guess.
gamers.
So, oh, that pasta is not like me. Let's get that cross product game going.
I got root 26 over root 3.
Wait a second. Oh, this man did it. He had the solution right here.
Root 26 over 3, you said, Jeffrey? Is that what you got?
Yeah.
Okay, then those are the same. So
Yes. So the formula and the process that Professor Jackson used is the same. It's like the D is equal to the magnitude of PQ cross V over magnitude of V. So his formation of PQ is he takes a point, an arbitrary point on the vector line, which as you said is the, the 0, 0, -1, and he forms a vector with Q, check,
yeah.
crosses it with the vector V, which is just 1, 1, 1, which is formed from this. Is just the fact that it's 1, 1. Where's the -1 supposed to be? On the, yeah, it's -1, 1, 1, 1 on the t's. The coefficients on the t's is -1, 1, 1. So there's that. Your v, you cross them, you get this. you take the magnitude of this over the magnitude of the v vector, which again is just going to be root 3, and there you go, 26 over 3. Yep, all right, so this is the formula. So that's definitely something that is to be taken note of. It didn't appear, this specific question didn't appear on the test because I looked through it on the test in this chapter. I made sure to look through it while we were discussing earlier, but I think this one might show up possibly because we did plane questions and stuff like normal vectors to planes and such, but either way, so that's how you do that. So let's see what other questions he has like here. The next one's parametrize the line that passes through the point 1, 2, 3 parallel to the vector -3i plus 7k. We're probably going to want to know how to do parametrization because it comes up a couple times here. So we'll just do 31. So we have a point, literally 1, 2, 3. And we have a vector is equal to -3i plus 7k. Cool. So parametrization. So we're just doing the reverse, right? We're trying to get it to where it's like a number 29. We're trying to get it in terms of x, y, and z.
You literally just take like x equals 1 minus 3t and y equals 2 and z equals 3 plus 7t.
Sounds about right, yeah. I feel like there's a formula about that somewhere. No, I guess not. Legend. All right.
So run me how you do it. I'm just trying to make sure.
Yeah. Okay, so I can explain it more formulaically because his explanation was great. Now I understand it. Parametrize the line that passes through point here. So a standard formula for this is going to be, because it's in terms of x, y, and z. So this is across the board. X, y, and z are equal to your point entry. So for x, it's like 0.1, plus or minus the corresponding entry times t from the vector. So in this instance, it's going to be -3t.
Yeah.
So you will have 1 minus 3t for x.
Then
And
it's going to
then
be
y, you will just have 2 because there
2
is no
plus
corresponding
7t.
t. No, there's no 7's on k. So there's
Oh yeah,
just
sorry.
2.
Yep, you're right.
And then z is going to be 3 plus 7t. And there you go. So that's across the board. That's how you parametrize. And now that we know how to parametrize, and we also know what that even, like what it means, like 29 and 31 are interconnected. And that means that we now know how to do all types of questions like this, regardless of how they're presented to us.
Yep.
Because if you want to get it into the other form that's given there, like vector form, we know how to turn the parametrized into a vector and vice versa. So we're set. 32 is another parametrize. I refuse. This is just by joining the points. This is just construct a vector and then pick a point. I refuse to do that. In exercises 33 and 34, we'll just pick 33 arbitrarily. Find the distance from a point to the plane. Never mind. Wait, actually, no, let's do a plane one. Let's do a plane one. This isn't a line, this is to a plane. So this time, in order to find a distance from the point to the plane, don't we want to find the normal vector of the plane that intersects the point?
So what we're going to do is we're going to find the normal vector of the plane. And then we are going to dot, or trying to read my notes, sorry. No, we're going to dot that with the vector between an arbitrary point on that plane and the point in space that we're trying to get to.
So we construct a vector?
Yeah, yep.
Okay.
And then we divide that by the magnitude of vector between the plane and the point. So like vector v.
But is that vector v? What are we constructing
sorry,
that
vector
out of?
n.
So that's the normal vector?
Yeah. So divide by magnitude of the normal vector.
Yeah, you take the magnitude of the dot product of the unit normal vector and you made PS vector.
Okay. feel like we might have done this one. We have a plane constructing a plane equation. Again, constructing a plane equation. Yeah.
So
So the normal vector of the plane is just the coefficients on the x's and y's and the z's. It looks like.
Yep.
Yeah, beautiful.
there it is.
Because that's also how you form a plane. You take the normal vector and you do the coefficients, and
Yeah,
then you
that's
solve
why
for it.
I went through my past test work and I found that this is the normal vector and this is the plane I formed. And the only place I could have gotten that is obviously from, yeah, the only time yeah, then I used a given point to find the D and then did that, so.
So after we found the normal vector and we're given the point, what do we do now?
So we have to do the normal vector dotted with the point that we have to construct a vector with our
At the
given
unit
point.
normal vector. So you have to find the magnitude of the normal vector and divide by it.
Oh, it's the unit normal.
And you dot your vector PS.
Oh, well, in the equation, did you dot it with the unit normal or did you dot it with the normal and then divide by the magnitude of the normal?
You dot it with the unit normal.
Oh, because in the original formula, someone else said it's the normal vector dotted with PQ over the magnitude of the normal.
The one in the book is
Yeah.
vector PS dot unit normal.
Okay.
And it looks pretty simple, so I'm going with that one.
Yeah, I mean, I have a feeling that there's a chance that they're the same equation. There might be some type of commutative property or something with dividing by the magnitude and the dot product that allows it to be able to spit out the same number.
I'm gonna be honest, I'm very lost.
Yeah, it's just so we take the normal vector, which in this case is just I minus j, and
Yeah.
then we form a unit vector out of that. So you will have the square root of 2. So you will have 1 over root 2 minus 1 over root 2, 1 over root 2 I minus 1 over root 2 j. And then you dot that with PQ, which is a constructed vector, with P being, wait a second, we're doing question what? 33.
33.
So PQ is a vector you construct with the given point and a point in the plane, like arbitrary point you can decide. So did you guys just pick like what are we left to pick here? You just picked 2 zeros or 4 0? Oh yeah, because it has it has to satisfy that equation. So yeah, so he picked 4 0. So you do tip minus tail. So you do 6 minus 4. Wait.
So wait, what do you get for your z for the point that you construct?
Z would just be -6 itself, right? Because there's nothing there. And then you dot them across, and then obviously you're dotting a 0, so the Z just disappears after the dot product. For the constructed, it should just be -6 since there is no third term to do this, so like tip minus tail thing, so it'll just sit away by itself. Although, because of the nature of tip minus tail, isn't our P our tail, right? So what ends up happening instead is if we have 4 0 as our selected point, which is Q, that's the tip. So it's 4 minus 6, so -2, 0, and then 0 minus -6, which means it's +6.
I don't think it really matters what's tip or tail because you take the magnitude at the end.
Yeah, you're right. So -2, 0, and then plus or minus 6 doesn't matter because here's the best part. You can just completely ignore the -6 since we're down a dimension and it's going to get dot product to 0. So then if you dot negative 2i plus, 0, whatever the heck, you're just going to be left with an I, obviously, because this is the last answer. And you will have, negative 2 over root 2, right?
For 33,
Damn it, it's root 2. What the hell is this?
it's root 2.
Just root 2.
How did I goof? Ah,
How did he get 4, 2, negative 6?
Oh, he
He
probably used a
Might have chosen a
different point.
different point.
He used like 2, -2 or something.
he did.
We should get the same answer though.
Yeah.
Technically should.
I got root 2.
Oh, how did you do it?
So I used the 0.40.
Same.
And so I just said, the -6 is going to cancel out with the dot product. And then you have the 0 minus 0 is the 0. So the j component cancels out. So the only thing I'm interested in is the I component, which starts at what? 6. And then you end up with the 4. So you end up with a 2i. And then your plane is going to be 1 over root 2i. And so 1 over root 2 times 2 is going to give you 2 over root 2, which is just root 2. And the magnitude of root 2i is root 2.
Wait, is 2 over root 2 actually just 2? Or root 2?
Yes.
Oh, what the hell? So I was right. I'm a dummy. I just
Oh,
said I said 2 over root 2.
Because
That's
you're multiplying it by the unit vector.
Okay. We spent enough time on this, I think.
oh my god, it's the same. That's disgusting.
Well, yeah, you just rationalize it.
Yeah, I hate it. All right,
I was a dummy too. You said it, and I was like, yeah, no, it's not the same thing.
all right, so we did a question that was
33.
yeah, find the distance from a plane to a point. Find an equation of the plane that passes through a point normal to vector n.
Okay, so this is actually really easy.
That's
Yes.
really just
Yeah,
plug
yeah,
and
yeah.
chug.
Yeah, so as John
Okay.
mentioned earlier, the formula for a vector or formula for a plane is ax minus x1 plus by minus y1 plus cz minus z1
Oh, okay, that's what
is
you're saying.
equal to d. So actually, we don't even need to do the x minus x1 here because we're given a normal. So we don't even need to
your
do
normal
that.
vector matches up with the plane.
Yeah, so our normal here
2x
allows
plus
us
y
to
plus z equals
Yeah.
whatever plugging in the points gives you.
Yeah, so this time it's even easier because the formula I just listed is the general formula for constructing a plane given points and only points. But as Jeffrey just said, we're given a normal vector. So the coefficients on this normal vector, the coefficient on the ijk, which is 2, 1, 1, directly correspond to the a, b, and c values, which are the coefficients of our x, y, and z in the plane. So that means the plane equation minus the d value at the end, which we'll get later, is 2x plus y plus z is equal to d. In order to find d, you take the point and plug it in for your x values, yielding you 7 plus or minus 2 plus 1.
Wait, 7?
Yeah, 6. 6 minus 2, which is 4, plus 1 equals 5. D equals 5. Therefore, our plane is 2x plus y plus z is equal to 5.
Yep.
Gamers. All right. Yeah, we did that. Let's see. So this is for points. I just explained the formula for points. I'm not going to explain it again. There's a couple ways to do it. So the first thing you need to do, I'll explain the process, but we won't really work these through because we're going to want to speed it up because we already burned an hour on one chapter.
Well, it was the first chapter. We haven't talked about hardly
You're
any
right.
of that in a long
That's a
time.
good idea. Something we're definitely going to have to end up doing another one of these tomorrow. I'll try and set us a time later, see who can attend what time's best. the method to do this. So you construct two separate vectors because all these points are in the plane. So you construct two vectors. It doesn't matter what vectors as long as they're two separate vectors that have preferably the same origin point. So PQ, PR works fine. Then you take that and what is it? Is it the cross product of PQ and PR is the normal vector, right?
Yep.
Just take the cross product of those, you'll spit out a normal vector. Your normal vector is obviously your ABC values, so that's one part. And then you now have that, and then what you can do is you can then take any point, really, right? Just straight up.
Any point. I normally do P because
Yeah, we don't even need to do the formula I listed earlier. You can still just take any point, 1, -2, -1, and 2, plug them in, solve for D, and you're done. That is something we did do. Plane
Yes, we
through
did.
a point and perpendicular. So that's what we just did previous, that method. So this
Yes.
is finding, and 3 is the question I just described, plane through points. You construct two vectors. I constructed them with the same endpoint like a weirdo. Made two vectors, then you did, fat cross product, spits out a normal vector, and then you're done. Cool. Then this.
It also doesn't matter as long as it's two separate vectors in the plane.
Yeah.
It doesn't matter like they don't need to share anything.
Yeah, I just do that just because it helps me visualize it, but it probably definitely doesn't matter. Find the points which lie. Nah, that's easy. I refuse to do that one right now. We're burning time. Find the acute angle between the planes x equals 7. No, that's finding vectors.
Yeah, I don't think we even covered stuff like that.
Yeah, no, we're not going to do it. Find an equation for the plane that passes through the point. No, this is just more manipulating of a vector to find a new normal or something.
By the way, just to go over slightly what you skipped, the thing that you just skipped, you use the definition of the dot product as the cosine theta of the dot product over the magnitude.
What, this one?
Yeah.
Yeah, okay. That would be this formula.
Yeah.
Find a vector parallel and orthogonal. That's something we did earlier, or at least intercept an interpretation of it.
A vector is orthogonal if the cross
Cross
product is
product
0, right?
0.
Yeah.
It's easy to remember because it's a statement.
Yeah. All right. Then what angle do the line of intersection make with the positive x-axis?
He didn't circle that one.
Oh shit, you're right. The line L intersects the plane at point P. Find the coordinates of point P and find it 3, 0, 0. Done. Probably not. Let's see. Intersect. No, it doesn't fit. Let's think a little harder. Intersects the plane in point P. Wait, no, the line intersects the plane in a point P. So where this intersects with this, find the coordinates of P and find equations for the line in the plane. I'm not doing this.
I remember that's when we covered solving system of equations. We had to do some nasty system of equations with this.
I think I have it right here, actually. But
you know the likelihood that's going to be on the test?
0, essentially. That's not showing up. It's literally, if we can even tell it's not showing up, because like you can really tell what's going to show up on the test by the density of circled questions. Like it starts to get a little bit wackier. You're like, oh, are we really going to do it? And then you get all the way down here, literally like the last question in the chapter.
Yeah.
You just circled it just because.
Call Jackson what you want. He doesn't normally go crazy on the test question.
Yeah, like look at this test. Look at this test. Look at this thing. I think I have like 3 pages of work. Yeah, straight up. This isn't a 100-point test, and this thing had 3 pages of work. There's like nothing here. This stuff isn't that bad. All right, let's start looking at this.
Now, normally he doesn't go crazy.
Yeah.
The makeup test that they had them do didn't look very nice.
I mean, I think one of the rules is the makeup test has to be harder.
Yeah.
Who knows? That's just how it be sometimes. All right.
Oh, not this again.
Yeah, motion.
Yeah, well, so without finding T and N stuff,
Ah,
it's
yes.
just a bunch of formula.
Formulas. Should we even go over these fully?
Yes, or at least one of them, just
Yeah, all right.
because it's formulaic.
Arbitrarily, we select one.
Yep.
I vote that you go over 21. It asks the same thing, and he gives us the answer in his notes.
Gotcha. Hitting it. In exercises 21 and 22, write A in the form, the formula it gives you at t equal to 0 without finding t and n. Okay, so here's a, t, and an. So he's just asking us to find a, t, and an. So here's our formula for that. So let's go back to the numbers we need. So we're looking at RT is equal to 2I plus 4. And no, that is the wrong thing. I'm not looking at the right thing. RT is equal to 2 plus 3t plus 3t squared I. And t is equal to 0 here. So screw that, not writing it like that. I'm going to reduce it. So it's 2I plus 0j, so nothing. Cosine of 0 is 1, right?
6, yeah, minus 6k.
Yeah, so just minus 6k. So that's a simplification. So now that we have our vector of 2I minus 6k, we can go over here and realize this is R of t, right? If this is motion,
we have to take the derivative. So
You have to take the derivative.
isn't this just gonna? All right, should we take the derivative of the function first before we plug in t then?
Yes.
I
Yes.
goofied. That was goof on my part. Now it makes sense. Plus 4 plus 8t minus, well, it's going to be plus 6 sine t. All right. Well, now we're in the v of t. So readjusting this, we're going to have 3i plus 4j, but then the k zeros, right? Because sine of 1 is 0.
So I think the first thing we have to do is we got to find a v of t.
Yeah, that's what I
V of
just
t
did.
is the derivative.
So I found the derivative and then I plugged in t of 0.
Nope, don't do that.
No, not yet. We have to find the magnitude and find the derivative of the magnitude.
Yep.
Ew.
Yeah.
I know for a fact that I don't think I'm
Thanks,
90%
Alex.
sure this showed up too. Yeah, it's right here. Or a version of this question is right here.
Oh, the girls.
Oh, there's 2 of them.
Dang it,
This
no.
showed up twice. This showed up twice. This is a big topic.
Oh, Ryan.
I don't mean to. It just happens.
What did he do?
All that girls.
You see, yeah.
You disgust me.
Oh, do we literally do we
Like a Soviet sleeper agent, you say those phrases and it activates me. I can't help it.
Like a Soviet sleeper agent.
Yeah. I see a
boy.
specific shade of orange and I'm like, I gotta kill the president now.
Oh jeez.
That's not a Donald Trump joke. I'm just making an arbitrary.
Damn, I was gonna yeah, for legal reasons that's a joke.
It's for illegal reasons. It's not a slam at the president. It's just a joke about conspiracy theories and Soviet sleeper agents.
Yeah, and you just saw the color of my wall because
Yeah, I can't
I
get
actually
over
wasn't thinking about that, but yes, that's true.
that's that my friend
they're
is
like
how
awful orange.
yeah. You want to explain the orange, Bucko?
I wanted dark red. My mom was like, you know what would look nice?
Burnt
Dark orange. So
That's scarlet
I wanted
orange?
terracotta red, like almost like a gray red.
So clay.
But- Yeah.
My walls are blue. All right. Either way,
Blue walls are the way to go.
I take it.
I see that now,
Alex,
but in 7th grade, I was like, I want be edgy.
Alex knows the right colors in this world.
See
Blue is
that?
the best.
There you go. Alex.
Yeah. All right.
I was
So
not
Do
even
we literally
paying
have to find the magnitude of the velocity vector?
Yeah,
Yes.
it's a pain.
okay, so you take the derivative of this. You don't plug in numbers. You find the magnitude of it, which means you do 3 plus 6t squared
Where
plus 4 plus 8t squared.
Yep.
Wait, yep. 4 plus 8t squared plus 6 sine t squared, all under the square root. So you can simplify it ish, but not enough to actually make it into a cool number. You're still going to have a square root and you're still going to have that sine probably.
One sec. Let me consult the notes to see if we're doing this right.
I
Just for
can,
my personal.
No, we are.
yeah,
We're doing
look
it
at look at these things. This is how you do it. This is what these things look like, and they suck. All right, so then we take that,
Mhm.
then you integrate.
no, we take the derivative,
Oh yeah, okay, I was freaked out again. So we take the derivative of this
which
Again.
is terrible.
again.
But
Mm.
wait, we have to finish. We have to we need to expand this, don't we?
Do we ever?
Yes, we do.
Do we ever plug in? Like, do we ever plug?
I believe at the end.
Not till the very, very end.
Okay.
So let's see. 36t squared.
Oh no! Look, you have to take the derivative again for a.
Yeah. Well,
You
that's
mean
not hard
No,
because
a
you're
of
just.
t is the derivative of the velocity, and
Yeah,
that's
but
what we're
look
looking
in the next function. The next function a of n is the square root of a, the magnitude of a squared minus the magnitude.
Yeah, a is an easy derivative though, because we don't need to find magnitude first.
Yeah.
Yeah, okay, that would be easy. That's what, 6i plus 8j plus.
The thing is, this isn't
Six
hard.
cosine?
It's just annoying. It's just.
So do you want to say this is how we do it and go on?
Yes, I do.
No, we gotta solve it for all the people watching.
Yeah, I
Fine.
think this is one we need to solve.
This is one we
21
need to, because this is definitely gonna
21
show up on the
in
test.
chapter 12. Well, yeah, you're right about that. So I'm just gonna make sure and see if he has an answer.
Yeah, it works out very nicely.
It does.
Once we get there.
You say that.
So this is the whole process. So let's see if we're right so far. So
Oh,
we took the derivative to get v, and we had the correct v, as I said earlier, under the square root. And then you take the
Mhm.
whole thing and you square it, and then he obviously already squared it underneath. He combined like terms, did it a little bit further, and then he tried to do a perfect square. Didn't happen. That's why he thought I saw something here. Then you just have to go over and be like, okay, it's time to just do the chain rule. And he did the chain rule. And
Hate the
then
chain rule.
he did the chain rule, but look, he evaluates AT at 0 immediately. So that's something to note. So you can evaluate the AT and the AN components respectively. So once he gets his chain rule derivative, he plugs in 0 for all t's and it spits out 10. So that's what you finish there. Then A is equal to the derivative of v dt, which, as I think Alex or Jeffrey said, is just the derivative, and it's an easier one because you're not taking the magnitude or anything. You just do that, and it spits out 6, 8, and then the cosine just comes back. Then you do the magnitude. Well, no, you just do the square root of it there, or square it there, and then an is equal to, yeah, AT squared, because we evaluated t as 10 earlier. You square that, it's 100, because the formula for an is a squared minus at squared. A is this, so you square that minus that, spits out 6 cosine because the hundreds cancel, and the 36 cosine squared is a perfect square, sits out 6 cosine t, evaluate at 0, cosine goes to 1, and then you have 10 and 6. This whole thing is nothing but this. Just this.
It's basically an overly complicated problem.
now
Basically, just
ideally, he will put this on the test. Like
Yes.
that's just going to be a factor.
I
of
have a
it.
feeling this one's definitely going to show up.
Oh, absolutely. I can tell you it's going to show up because on our test, this showed up twice in a
Mhm.
row. Like questions like this showed up twice in a row.
This one's important.
Which he never does. Like he
Yeah,
rarely.
This is the
if ever,
closest
does.
we got, but it wasn't even the same type of question. It was a plane. It was the equation of the plane given a point and a vector. Yeah, point and a vector, and then given point. So it wasn't even, these are two different processes anyway. Similar, but not quite. All right, so that's how you do that one. Is that it? Bro, there's like nothing here. Okay, we're done with 12. We did what we needed to. Let's just make
You
sure
do
this-
realize that means that question is going to be on.
Yeah, all right, everyone.
Like that.
Everyone who's listening, this is gonna show up. You need to know how to do this question. These types of questions, they're all pretty much plug and chug with the equations. Just don't mess up your derivatives and remember when you need to evaluate at the given values.
Oh wait,
Do
so
number
what chapter is this?
15.
That's 12. So let's look at the
Is that chapter
breakdown.
12?
Chapter
That's going to
11
be
and
at
12.
least like
There's 4 questions
almost
from
like-
chapter 11 and 12. I can guarantee you at least one of those 4 questions is what we just looked at. Maybe even 2. So
Yeah, probably. Chances
that
are.
question is going to be at least 9 points on the test,
yeah, so make sure you know how to do it.
if not 18. So
Because then it could be 2. So make sure you got it.
Find the length of the curve.
That
Boom.
covers 12, and then this is still just the same thing, except this one's.
So if you know how to do that, you should be able to get a 10 on the final exam.
Oh yeah, so find the length of the curve. Isn't this just
The length of the curve formula
Five.
is terrible.
This, right? this?
No, is it?
Yeah,
I
this has to be
think
it.
so.
Yeah, absolutely. This is
Because
it.
it's velocity and you got your 2.
Yeah, that's it.
Yeah, no, okay.
Magnitude of velocity.
Oh God, do you know what that means? Because that's another chapter 12. That means this test was half chapter 12. 3 in a row of chapter 12 questions. Oh, that's awesome. All right, well,
And-
know
And
how to
guess
do
what
this.
that means? That means like
Yeah, so the length
that-
of the curve. So here's how you do these real quick. I'm just gonna explain it since I showed it on my test, but even so, you take the derivative of this to give you your v of t. You get the magnitude of v of t, and then you integrate it across these bounds. There you go, done. All right.
Yep.
Chapter 13 time.
It's a simple spell, but quite unbreakable.
Chapter 13 time. Did we have 4 exams or 3 in this class?
4.
Couldn't tell you.
We took 4.
yeah,
I
that's
can tell
right.
you.
I got 400s and then like a 90 something.
Stop flexing.
Hmm. Sorry, not all of us
Even you got something like
are
that.
Shut up.
excel at calculus.
All right, let's go. Gamer time. Find the domain and range of the given function and identify its level curves.
I don't like level curves, gonna be honest with you.
Homie's got to give us a derivative review because we're incompetent. All right.
Oh,
I love derivatives.
Just looking through this stuff.
I'm not looking forward to writing all this down tomorrow. That's what I'm going to be doing all afternoon. I'm going to be writing all of it.
Yeah, we're
I'm
gonna
doing my computer science final because it's due tomorrow, and I haven't even
Put a
started on it.
bullet in my head.
Yeah, the
in my
thing is,
head,
when it comes to
put
this
a
one, I
bullet in
think,
my
let's
head
check this
for
breakdown
the
again. 13
truth.
and 14. So now we have to cover, so we'll probably just get through 13 today, and then we'll do
Yeah.
14, 15 tomorrow.
That sounds good.
We'll have another 40 minutes on this to make it exactly 2 hours. I don't want to make it,
Any
the
longer than
longest we've
that.
ever had. We've had one of those 2 hours and 30 minutes once, but we
To
don't
be
want
fair,
that
this
again.
is the final, so it kind of makes sense to be the
Yeah,
longest.
two, yeah.
but-
So even so, we'll do 2 separate sections because obviously we won't be able to get through all of them. So we did 11 and 12 already. We'll do 13 and then 14 and 15 for tomorrow. 14 and 15 should go quicker since they're closer. We remember them better.
Yeah.
All right, so when it comes to 13 stuff, let's look at the types of exercises in 13. This is a huge chapter.
Oh boy.
All right, so it looks like this is his last one. Sensitive to change. Ew. Did we even get a question like that?
Nope, that's not gonna be on the test.
Uh,
Screw it.
I
I'm
don't-
pulling up my past test.
Wait, what
I
number?
don't, that sensitivity to change,
like
I do not
s-
remember that phrase.
It's, well, I get what it's saying. It's saying that what
See,
po-
Jeffrey, look, not, I mean, see, John, not all of us can be legends. Look at that
Mm.
abysmal score.
Wow, an
I got an
88 on a
85
college
on the
test?
last
That's
test.
terrible.
I got a 90 on the last test. I don't even know how.
I got an
Yeah,
80.
me neither.
what did I make on
Alright,
the last
We're
test?
done with this. All right. I couldn't tell you. I don't remember writing this down. I couldn't tell you.
Couldn't.
Boy. Ew. My handwriting sucks. This had 8 pages. Oh wait, because of the note cards. He allowed us a note card and I submitted 2 separate pages for the note card.
Yes.
It's called making use of your
This is
your
actually
skills.
really good that I have the note card.
Yeah.
Because that means all the form. This is good. This means we can look up our past note cards or have them. Because I know I don't have mine anymore.
I forgot to submit the note card for the third
Oh,
test.
dude, saddle functions. Remember those?
Yes, I do. To a point. So this is the type of stuff
That
we
makes
should
one of
expect to
us.
see. This thing,
You know,
couldn't
the
tell
tests
you.
say I apparently knew it during the test, but right now, not a lot.
Does he like annotate? Does he do?
That's why I don't
Nope.
like doing math finals like this, because it's like there's way too much to try and remember.
I'm trying to see if he annotates because that'd be pretty
No, he
baller.
doesn't.
At some point you're going to break,
Oh, bro.
because I'm
that's-
about to break.
Oh, does he?
But-
Oh,
But what did I do? But tell me, what did I do?
Mr. Jackson, what happened?
I don't know. At least this means that, I did the first one correct. I did the second one correct. And I messed up the third one. I messed up the fourth one. I did the fifth one correct. I did the sixth one correct. So if we need to
Check your
review
inbox, you heathen.
what?
146 message.
are you thinking? This isn't new. He's
Only went
never
up
had-
23 from last week.
Bruh, stop roasting how many inbox. I don't look at them. Why would I? I
Was
get
that
it.
your teacher sent you information on your finals? That doesn't matter.
Yeah, I don't need to see that. All right.
I have the
we're back to
roadmap
here.
inside my colon.
Exactly. All right. It's gamer time. Find the domain and range of the given function and identify its level curve. Sketch a typical level curve. The domain and range of the given function. This is all reals, right? There's no problems here.
Hmm.
Wait, no,
This-
that's a circle. Right?
It's an
That spits
ellipse.
out
I think it's like an
Yeah.
ellipse or
an
something.
ellipse.
It's an ellipse, I think.
So it does have a domain and a range.
Mm-hmm.
Domain is all X's and range is all Y's, right?
Yes.
Okay, so we need to figure that out. So let's think about this.
So what you're gonna want to do for these is you're just gonna want to assign a z value, and then from there it's just a simple circle. So like if z equals 0,
Mhm.
you know that it's just a circle with radius 0. If
Mhm.
z equals 1, you know that
Well, it's technically an ellipse, as someone said, because there's a
That's
oh
scalar
yeah,
on
yeah,
one.
you're right,
radius,
ellipse,
so-
ellipse, not circle. But you're just gonna change the value of f of x, y on the left and evaluate it as a circle, as an ellipse, and just sketch
like
that.
this.
Yes, yep, just like not what you did there. So it's
Gamer.
really not that hard if you can visualize a circle.
Yeah. All right. So. Yeah. So this is a ellipse / circle.
With a domain of 3 in any direction.
How do you know it's 3?
I'm pulling it out of my
Yeah, so
I just assume so because the square root of the x would have been 3.
no, so domain for number 1 is going to be all real numbers, because no matter what you plug in for x and y, you will get a z.
So domain and range are all reals.
Yes.
Yeah, so that's what I thought. So that's not the actual. So domain and range, I was confused as whether or not I was asking for like the limits of the function,
Mhm.
but it's not. It's just asking what can you plug in. So like, let's look at 3 real quick. That has limitations. You can't put 0 down there.
So there's
Eh,
3 ways you can have limitations: a log, a square root, and a fraction in the denominator. The denominator cannot equal 0. Logs can only be positive and not equal to 0. And then square root can equal 0, but have to be positive. Positive and equal to 0.
All right, so those are all the possible, limiters for all functions that we are familiar with. So knowing that, the next step is we need to sketch level curve. So we know this is going to show up. You put it on the test, sketching a level curve. This is a circle because of the nature of how it evaluated, right? Not sure why it's a circle here, but it's a ln function. There's probably something I did somewhere. Oh yeah, I think what I did was I raised it. Yep, this is exactly what I did. Yeah, I set it equal to 0, raised the 0 to this, and then set it to 1. Yeah, so this is just me being a wacko, and it worked.
You crazy son of a gun.
So that's how it works sometimes. So this is the same thing. Set it equal to 0, as Alex was saying earlier, or set it equal to z, and then evaluate at various radial values. So set it equal to z, and then be like, okay, let's set the radius equal to 1, 2, 3, and then doodle it. And there's that. And then identifying level curves is a matter of, is that it? I don't know if this
Yeah,
is.
that's it.
Oh,
So
there's-
evaluating level curves is it gives you a z. You have to graph it. So like what you did, you set it equal to 0 because that is one of the things that they asked you. He asked
Yeah.
you for 0, natural log of 4, and natural log of 9.
Mhm.
And so you went about solving that by saying you exponentiated it or raised both sides to e,
Yes.
and then you got something that you could graph, and something that you could graph is a circle formula. So
Yeah. So that's that. And then I think I doodled a level curve here, which is this thing. Compute this, but it didn't ask us to compute here.
sketch a typical level curve.
Yeah, so we didn't have to do any computation here.
Oh, wow.
Or
Okay.
a partial
Sounds
derivative.
like
So this question is going to show up and it's just doodling. Now part 2 of this question is I think what we're about to do. Looking at something like this. In exercises 19 through 24, find a partial derivative of the function with respect to each variable.
Easy.
Okie dokie. So does that mean we're doing it twice, one with R and then one with theta?
Yeah.
Okay, so do you guys want to just do 19 partial? I honestly believe there's not a single person in this class who has problems with partial derivatives. It's honestly kind of the bee's knees with regards to topics in terms of just easy to grasp pretty quick. But just in case. G of R theta, this is question 19, is equal to R cosine theta plus R sine theta. All right, let's take the partial derivative with respect, I wrote that wrong, partial derivative with respect to, let's just do R first. Yeah, it's just going to be cosine, it's going to be cosine theta plus sine theta because you treat as a constant and the R drops out. And then if we do the partial derivative with respect to theta instead, we will have negative R sine theta plus R cosine theta.
that's probably the easiest one you could probably get.
Do you want me to do a different one? Want to do 22? Because it's a 3-dimensional one and it's within a function, so it might trip some people up.
I was thinking of one with fractions because that forces you to do, whatchamacallit.
Well, ln, right? Ln, derivative of 1 over x is ln or whatever.
Yeah, stuff
derivative
like that.
of ln is 1
Chain
over
rule
x.
and things.
Yeah, I flipped that as the
Hey,
integral
Ethan,
of
do
1
you
over
want to do 21? Do you want to do the resistor one?
Is that what that's supposed to mean? Sure, why not?
Yeah, well, that one is just the equivalent resistance.
Yeah, you're right. If f were equal to some value 1.
Yeah.
Yeah, because then the
Looking at
total.
24 makes me feel bad.
What?
We're doing 24.
No.
24?
We're doing 24. All All right, is equal to 1 over 2RL square root T over pi W, gamers. So,
We do not know the answer to this one though.
oh well, let's start with R. All right, let's start with, this is just a test if we know how to do the derivative. Let's start with R. So R is at the -1, so if you brought that up, you subtract 1, multiply, you multiply across, it's negative.
So this is kind of easy. So it's like -1
1
over R
to
squared
R squared L square
times
root
everything else.
T over pi W. So the functional principle that works behind partial derivative is that you take the derivative with respect to the variable that you're taking the derivative with respect to at the time, and then everything else is treated as if it were a constant. So with respect to R, it's simply -1 over 2R squared L times the square root T over pi W. There's that. Now let's do L. L is identical, except it's just going to be -1 over 2RL squared instead. And then the square
Don't we
root
need to
term,
take?
square root term is the same. Then if we do T, so square root of T, so this is going to stick some fractions into the game, right?
Nah. So what you do is you split up the square root, so it's just the square root of T, and then everything else is a constant. So you take the derivative of square root of T.
Well, yeah,
The
shouldn't it still bring a fraction? It's going to add like a 1/2.
Yeah, I
It's
mean,
going to
yeah,
be,
I
so it's
guess.
going to be what,
Yeah.
like 1 over 4 RL times, isn't it 1/2 minus? So then the T is going to flip down.
Yeah,
It's
so
gonna
it's the
be,
square root of T pi W.
well,
So
1
it's
over.
1 over 4 RL square root T pi W.
Well, square root 1 over T pi W, right? Because the T would be, square root minus 1 flips it to the negative. So then it's going to be the square root 1 over square root T pi W. Should be.
Because that's what I was saying. I was like,
Yeah. All right. And then the last one, which is W, is probably the most
That's where
annoying
things-
one because that's the negative under a square root.
That's chain rule, boys.
Hmm.
Let's go.
Yeah, we're gonna quit there. I'm done. All right, let's keep going. It's right about the chain rule. Now it's done. But essentially, this honestly, first off, it's four separate.
variables.
Yeah, it's 4 separate variables, so that this would never even show up in the first place. You're more likely to see something like this, this. Everything else is maybe even this, although this is a really easy one because it's all the same. But either way, partial derivatives, it's just a tool that we use for more complex computation later on. Yeah. All right. Second order partial time. Do we want to do 25 or 27?
Let's do 27.
Probably just because it has.
So when they say second order partial, does that mean it wants us to do partial x then partial y of the partial x?
If
That
I
means
remember
all of
correctly,
them.
yes.
I
That
think
means
it
the
wants us
second
to do
partial of x, the
all
second
of
partial of
them.
y, the second partial of x and y, the partial of y and x, all of them. So all
Oh yeah, because
four.
it would be fxx and fyy, and then there's fxy and there's fyx.
But I
It's
think
really only 3 though, because x, y, and y, x are the same.
yeah.
Yeah, here's something like that. Find partial f, partial fy, and then partial fyx. So this is what it's asking. So this is the fyx part, which is,
See, that's one of the 3 or 4.
can we just do
the
one?
different ones.
Can we just do one? There's no way it's gonna ask us for all of the permutations of a second partial derivative of a function.
Well, for this one, the x one, 25, is really easy to do the x one
Well, yeah, because it's only got one.
because it's actually the second derivative of the XX derivative is
It's
just going to be 0.
Yeah. And then the yy is gonna. It's just
YY is
gonna
going to be dumb.
Yeah, yy, if it drops a y out, but then the other one becomes a negative x over y squared. Then you do it again, and then it's just gonna be what,
X over Y
2,
cubed.
2 though, right? It's
X
gonna be,
over 2y cubed. Yeah.
is it? Yeah, because it's fractional, right? Wait, no, it's
Uh,
not fractional. It's not fractional. It's 2x over y cubed, right? Because
No, because I'm pretty sure it's the original times the derivative
No,
with
you're right.
respect to that of
No,
the
because isn't
of
it,
the
Ethan's,
bottom fraction.
Ethan's right.
yeah, because we're used to treating it like this is a root. If it was a root problem, then that's what would happen. But in this instance, since it's just in the denominator, the partial with respect to y, the first partial, is just negative x over y squared. So then when
Yeah.
you do it again, it's negative x, y, negative 2. You multiply the negative 2 out to the front, which is now 2x, y, negative cubed. You
Yes.
flip it back, that's 2x over y cubed, and that is your yy. So we have the xx, we have the yy, and then we could do both permutations of either or. But do you want to just do the, do you want to just do an xy just because?
Yeah, if you want to do the XY, that would be the easiest one, which is the
It
Y,
basically brings you to the first Y.
which is negative Y 1 over Y squared.
It should be.
Yeah.
Yeah, because it would just get rid of the x from the yy, or the y from the partial y. All right, there's that. Yeah. My voice is dying because I've been here since I've been doing this for
2 hours later.
3 hours.
Started,
Yeah,
we
legend.
started at 7.
Yes.
Yeah, 7 your time. Sorry, yeah, 6
Yeah,
our time.
because
so.
it's 10 my time right now. Yeah, because I did my hour and a half for solid state. That was some. All right, let's continue with chain rule stuff. Let's see. This is just. Wait, what is he talking about here? What is he asking for? Find dw dt.
You know your favorite, Ethan, the little branch diagrams.
What? Ew.
The
I
thing
never.
that you refuse to do,
Yeah, I don't do it.
the path diagram, that's what he's asking for. But he's asking for the middle thing. Yeah, that. Exactly.
Beautiful. Yeah, I refuse to do branch diagrams. I think they're dumb.
Well, I mean, you don't have to do it, but yeah.
Just because it shows up on the test doesn't mean.
Well, I mean, it did show up on the test, and as you can see, I did not use the branch diagram. I refuse. That's just how it be. All right. Let's just do one of these then. So find dw dt at t0 if w is equal to this. Are you sure this is asking us to just find the center? Because this looks suspiciously like having to find the whole thing.
No, I mean,
Yeah, it looks that
Wait,
way.
but it says when s is equal to 1, t is equal to 1/2. Does this give me an s? No, it just
Well,
says at t.
I have a feeling we sub it at the end, maybe.
Yeah, but so this
It's
is only
what-
giving us an extra variable, so that
yeah,
means
what you did.
t, y, t, w, t. So this is a 3 variable function of w, and this had an extra spare variable of
Yeah.
s. Although what I did here is I pre-evaluated these functions numerically. Yeah. So let's look at this then. dw dt of w is equal to that, x is equal to that, w equals to that. All right, so it is always, the formula here is wx, wy, wz, and then times partial x, partial y, partial z. So it's just the same formula. So that means
Got to take w with respect to x. And
yeah, so that
y,
starts
and
as just going to be cosine of x y plus pi, except it's actually y cosine xy plus y plus pi.
Yep.
Yeah. And then times that is times the partial with respect to just x, the function of x being e to the t, and t is equal to 0.
What?
So it says t is equal to 0.
Okay, so yeah, 1.
Yeah, regardless of the outcome, this is just 1. Then the next step is take the partial with respect to y of w, which luckily we don't have to go any farther than that. So take the partial with respect to y of w, and that's going to spit out an x cosine. So plus x cosine xy plus pi.
Yes.
And then times the derivative of partial derivative of y with respect to t, which is 0. But either way, let's just do it.
1 over t plus 1, which is 1 over 0 plus 1, which is 1 over 1, which is 1.
Wacky, a lot of ones there. All right, so now we have, we could just say it is x plus y times cosine.
Yeah, and so what a good thing to do
xy
now
plus
is to
pi.
figure out what x at t equals 0 is. So x at t equals 0 is 1, and y at t equals 0 is 0.
Yes. So y zeros, x is 1, y zeros, x is 1. So now simply cosine of pi. Cosine of pi, which pi is 90 degrees. Cosine at 90 degrees should be 0.
Yes. So what is
Wait.
that 20?
It's 180 degrees. It should be -1.
You fool.
Let's see, 29. What is that? 13, 29.
Cosine of pi is -1. Yeah, I had to correct myself. Pi is 180 degrees. It's not 90 degrees. It would have been 0 if it was 90 degrees, but it wasn't. It wasn't pi over 2. It was pi. That's my bad. All right. The next one like this is the same thing, but it adds an extra layer of complexity. Not only does it add a third variable, which means instead of that question we just did was this portion, this term, this term, this term. Didn't have this term yet, but it's done the same way, just with respect to z instead. But what it also does is it adds an s. So as you can see, this problem on my test is literally something that showed up. It showed up before and it's going to show up again. You need to know how to do these problems.
Guess what?
But in the
That
same,
means it's on the final.
yeah. So in the same boat, the same thing. It's done. These things are done identically. The only difference here is now that you have, this ds or whatever. What did I do that was different at all? Yeah, I simply pre-evaluated.
So you don't do anything differently except for you leave s in there and then you just solve it at the end.
Yeah. So unlike last time where it was just t's, this time you won't have just a constant or a number. You'll have s or something like that, s or something, and then when you plug in and numerically evaluate it across the board, at the end of the day, these things spit out a number, and normally it's a nice number. This one is R and S. This one looks like it would also spit out a nice number since it's rocking pi with trig functions at a 0. But we only have like 15 minutes left, so I'd like to hit something else. Do you want to try directional derivatives?
Wait, just a minute. So 1329, I'm going to check our answer. 1329 is -1. You're right.
Gamer. All right. So 31's done with the same process. We don't need to go over that whole thing again. Find the directions in which f increases and decreases most rapidly at p0 and find the derivative of f in each direction. So let's see if he mentions a lot of directional derivatives.
That's just the gradient direction, right?
Yeah, it's this thing. Sketch gradient vectors. The derivative in the direction of any unit vector u is just the gradient times u, which means given a vector, you take the gradient of this, evaluate it, and then multiply. And the gradient, oh, it's the dot product. It's not times. Sorry, that's my bad. So it's the partial xi, partial yi. All right, let's do this one. This shouldn't be that bad. All right, so first step here is we need to form a vector by taking the gradient of our given function. So we take gradient. I said gradient, but I meant partial derivative gives us the gradient, which is a vector. So we take the partial derivative of this function with respect to x first, and that will give us our I component, or our I coefficient. Component was better. So we would do the partial with respect to x of cosine x cosine y is going to spit out negative sine x times cosine y, any order, it doesn't really matter. Then that is the I component. And then we do the partial with respect to y instead. So now we just have negative sine y cosine x, and that's our j component. And that's all we have with that. So there's our gradient vector. And then the trick is, though, we have a point here, and we should evaluate it at that point, I believe, and then dot it with v. So we have pi over 4 for both points. So what is sine of pi over 4 is the question. Is that root 2 over 2?
I know pi over 4 is root 2 over 2.
Okay, so we have negative root 2 over 2.
So it's all going to
times-
be root 2 over 2. So it's root 2 over 2 times root 2 over 2 minus.
So it's 1/2. Well, negative 1/2.
Is cosine of pi over 4 1/2 then?
Yes,
Yeah, because the
minus
square root's
1/2.
and,
Wait, no, yeah. So it's root 2 over 2 times root 2 over 2 I minus, yet again, root 2 over 2 times root 2 over 2
Yeah.
j.
So the
And-
components are negative 1/2 and negative 1/2.
Negative
Yeah.
1/2 I, negative 1/2 j. Beautiful. And then the last step is we dot product with v. And what do you know? Negative 3/2 I. Wait. Dot product yields a sum. I'm a dummy. Negative 3/2
I prefer silly goose.
minus 4/2, which is just 2. So negative 3/2 minus.
So it's negative 7 over 2.
You betcha. At least that's what I say.
August, that's none of it.
Someone should look up the answer.
It's none of it. So
I remember
increase
back when all the math you had to do was fractions and decimals.
So did he show us this one?
Yeah, it's negative 7 over. I hope that's 2.
No, that's 10.
What is that?
And that's what the back of the book says as well. Negative 7 root 10.
Where did we goof? Look.
How did you get 3/5
So-
and 4/5?
So the negative 1/2 I, negative 1/2 j is what he got as well.
Mm-hmm.
Okay. So how did you get 3 and
Because he got like
3?
something over 5. He got 1 over 5.
No, root. We have to do it needs to be a unit vector. We need to dot it with a unit vector. That's where we do.
Well, that's not that bad. That's not that bad. We just take, 1/4 plus 1/4, right? 1/4 plus 1/4
It's 25, so it's 5.
over the square root. How is it 25 if it's
No, it's the
m-
no. We did the
magnitude.
second one. We did the other one. We have to make the other one a unit vector,
we have to make the other one a unit vector. You see, I wouldn't have thought of that. The sad
So-
thing is I've probably done like 20 of these in my lifetime, and I just don't remember.
So the 3,4 one, we have to put it in unit form, which is
Yeah, 9 plus
3
16,
over 5 and 4
25.
over 5.
Yeah, there you go.
Is
All right, I'll let this
negative
scale us up by
3/5
5.
minus 4/5, which is negative 7/10.
Yeah, we just missed out by a 1 over 5 multiple. Oops. It happens.
Mhm.
All right. Same process is 39. Same process for 39. Just a slightly more complex derivative potentially and a third dimension, but same process. 41, derivative in velocity direction. Find the derivative of this in the direction of the velocity vector of the helix. What? Well, let's take the derivative of this to get a velocity vector. And it gives us an evaluation. So we have. Oh, this is gonna be great. I can already see what's gonna happen here. All right. We got negative 3 sine 3t I plus 3 cosine 3t.
Shouldn't it be 3, well, -3 sine of 3t?
Yeah, that's what I adjusted it. But yeah,
Trying to trick me.
No, yeah, I was being a nerd. J, and then the last one's just luckily 3k. And then this time we can evaluate this immediately at pi over 3. So this actually ends up being sine of pi cosine of pi because the 3's will cancel. So you have -3 times sine of 90, which is out
No,
of
sine of
phase.
180.
Yeah,
which is zero.
damn, I did it again. Sine of 180, which is 90 degrees out of phase with cosine. So if
It's
cosine,
0.
yeah, I was gonna say if cosine is -1, then cosine's got to be 0. So that's zeros. So there's no I component. Cosine will just be -1, so that's -3 j, and then k is just gonna be pi plus pi k. That's funny.
No, it will just be 3.
What? T's pi over 3? And oh, damn, you're right. That's that. All right, 3k, and then we take that.
So 0, -3, 3.
Yeah, and here's what we have to do now, though. We have to do that gradient dot product. So
Square root of 10 is
so this is going to be, this is weird because this would be yzi plus xzj plus xyk is our gradient vector. And then we dot that. So I guess it makes sense that this will have x, y, z's in the final answer. So we take that, and then you're right, we have to scale this other one to a unit vector, which is going to be the square root of 18, right? Which breaks down into 9 and 9.
9 and 2.
Damn, yeah, you're right. So what is this, 3 root 2?
-1 over root 2
So that would be
over 1 over root 2.
1 over root 2, and then plus 1 over root 2. And then we do the dot product. There is no I component, so we can eliminate that off the bat. So then we have -xz over root 2 plus xy over root 2. Therefore, we can combine this to just be zy over root 2 with the negative x's canceling.
Wait, what?
Right? Since it's a dot product, it's a sum. Who knows,
I'm-
man? I couldn't tell you. Let's look at the
I'm
answer.
very much confused, man.
Did they have 41? He didn't do 41.
No, in the back of the book says it's pi over 2. Root 2.
How did he do that?
Consult the walkthrough.
No, because look, it's just find the derivative of this in the direction of the velocity vector. So if you do the partials, these don't evaluate into numbers, do they?
No, he doesn't have the answer.
Yeah, I looked. These don't evaluate into numbers, right?
No.
So what? I have no clue.
I don't know.
Let's see if there's something like this in the test. All right, not up here. This is compute at some point. We've done that already, but that's just not because we don't have a point here. We did that. That's nothing. Shouldn't it work? Did I answer 2? Did I answer 3 twice? No. Estimate change. That's something we'll need to know how to do probably. We'll hit on that tomorrow. We did this already today. Max and mins. This is the crap. This is the stuff. I hate that. This beauty. All right. I don't know why that's wrong. We'll just assume that's wrong for the reasons. What I should really assume is that the odds are low that this will show up. This type of question, since it didn't show up on the exam. The ones on the exam are far more elementary. And to be honest, if it was easy, if the problem that showed up was easy on the original in-depth exam, it'll probably be an even more general problem on the final because it's more spread out, less in-depth. I mean,
It's not physics.
just traditionally. Yeah,
Not rocket surgery.
rocket surgery, my favorite type. when they attach a scalpel to a model rocket and fire it off, so I get sliced in half. It's my favorite.
Mm.
Directional derivatives with given values.
That's
Dr.
the goal.
Propulsion. That
So this is
he needs heart surgery. Help.
oh, so this is what I just looked at in my test copy. So this is also pretty simple. Yeah, so this is like find the derivative of f at this in the direction towards this. So this one is probably a really good example to talk about. So for this one, in this, evaluating at a specific value, where is it? No. Okay, it's higher. It's much higher. How do I keep missing this stuff, dude? What am I doing? I have no clue what I was talking about. I don't know where I saw it. Either way, so finding directional derivatives at a specific value goes like so. So what you would do is you would do this example specifically, you would take the derivative of a given function, which is it even given? At the point has a derivative of 2 in the direction towards 2, and a derivative of -1 in the direction of, oh, this doesn't even have a function. Oh, this probably isn't a good example. He's not going to give us this.
No.
I wanted to talk about, I want to talk about if you had an actual function here, you would take the directional, you would take like the gradient of the function evaluated at this point, and then dot product it with a vector you construct out of this point and this point, since it says in the direction towards the point. So you would construct a vector to dot product. So this is a good question to understand if you were to actually give it as like a real question. This one's like a super theory question that's obviously not going to show up. That won't show up. So really it's just like, we talked about these. It's like these types of questions now, but we're approaching the pause time. So we'll take a pause and remember that we just hit like the gradients, tangent planes, and normal line stuff.
Yeah.
Okay.
And we'll come back to it. So
'Cause
tomorrow
I'm
is
about to
probably,
break.
yeah, tomorrow will be probably our shorter day.
Finishing
Shorter
up
time.
13, 14, and 15.
Yeah, it'll finish up 13, 14, 15. And then what we'll do is we'll probably also make the formula sheet.
And I will probably make that and send it in the chat.
Legend. All right.
Wait a minute.
What's up?
Sorry, I'm on Shmy Funny, and one of the posts is about an actor, Imran Monahan. He was in
Mhm.
Joker.
Yeah.
And on his credits, movies and TVs, it shows The Mandalorian on there.
Legend.
Which is interesting because he also plays a character in a Star Wars video game
Who
as
is
a
it?
Jedi.
Who is it? Who does he play?
Cal Kestis
Gamer. That's what he
from
is.
Star Wars. I can't remember. I've played it. That's why I didn't do well on my last Cal final.
Ouch.
No, well, on the first one, but that was
Wait,
also
is it
on
like
his
the
Cal.
new one?
Yeah. Let me pull up my Stan. Where is it? Jedi Fallen Order, that's it.
Yep, Fallen Order. Well, I gotta go be a gamer and finish my physics exam.
I'm gonna
Oh,
eat
boy.
some cinnamon toast and try and feel better.
I gotta get something to eat.
I'm gonna lay down
Okay.
on my face and cry for 20
Legend.
That's me at 12 o'clock when after my physics test is done and I can't work on it anymore.
Oh boy.
I'll just
When I go
I'll just
cry
lie in
myself
the
asleep
dark,
by
staring at the
code.
ceiling.
How are you
fall
feeling?
to-
How you feeling about that? How you feeling about that test?
What
Gamer?
test?
Your physics exam. How you feeling about the questions so far?
Well, can you stop the recording real quick?
I did stop a while ago.
No, you
Says
didn't.
recording.
It is? Oh, that's
Yeah.
dumb.